Hello grade 12s, welcome to yet another video, and today we're going to be trying to work on paper 2. Okay, I downloaded this paper from stanmorephysics.com. There's also a good guy, a good gentleman, I think his surname isn't Dolly. He forwarded me this paper, and unfortunately it's the same paper, so yeah. The one problem with this paper is that it's incomplete. Okay, there's question 4 and 5 missing. Anyway, we'll just work with what we've got and see what we can do. So this, in a way, is going to demonstrate some mental preparation for a paper 2 exam in math for grade 12s. Okay, otherwise we will just talk through it while we solve. All right, now I cannot overly emphasize instructions like that because they already tell you how to work out issues here, okay? And then, of course, the issue of rounding off. Here, again, we're told to correct to 2 decimal places. So make sure you understand these type of instructions because they will hurt if you're not careful. So the main thing here also to note is that these diagrams are not drawn to scale. So don't try to read directly, but get the implication at least. And then of course you are given a formula sheet if you be in a need of some formula that you've forgotten. Okay, let's not waste time. Let's get to question 1. So as you know, question 1 is statistics, as well as question 2. So usually very straightforward. Here you just need the formulae. You need the formulae and just logic in general here. That's the preparation in your mind for these kinds of questions because they're pretty straightforward. All right. We're told here, the owner of a small company wishes to establish whether advertising in a regional newspaper is effective. Okay, the table below shows the amount spent on advertising and the corresponding sales figures for the last 9 years. Okay, now the amount spent on advertising in rands is those trends over there, but if we inspect these ones, they are actually they're just put randomly. They are put randomly, so sometimes it makes it a bit difficult to figure out, but let's just move on. That's just what it is. And then the rands, the sales in rands are as listed there. Now we're told you determine the equation of the least squares regression line. Of course, here we've got what we call bivariate data. Bivariate. So meaning there's 2 variables, x and y. Okay, not a problem. So here we just put things into the calculator, straightforward. So let's just go for it. So we will put things in the calculator. So we go to mode. And then we go to stat, which is 3. And then here we're going to choose that a plus bx stuff, which is 2, which is the bivariate data, whatever. Okay, we start. X was 21,300. And then we've got 23,700. We've got 24,800. We've got 35,40. We've got 24,100. We've got 46,80. And then we've got 22,400. We've got 35,250. We've got 29,110. Okay, so 21,300 goes with 311. 500. And then the second one goes with 326,700. So this one is 349,200. And we're talking about big bucks here for 70,000. 316,100. We've got 564. 200. We've got 314,000. We've got 487,300. We've got 392,900. Okay, so guys, once you get to this, how many panels do we've got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So everything looks all right. And then we hit our AC button, and then we go to Shift, Stat, and then we go to 5, which is a regression. So it says determine the equation of the least squares regression line. So this is 1.1.1. First of all, we want to know our A, so which is option 1. So this thing is a bit tedious here. A here is going to be 1,730, because we round off to 2 decimal places here, so this is going to be 2, 3. Okay, and then let's look at our B. Again here, unfortunately, you follow the same procedure as many times as you need to. So this one gives us 13,96. Okay, not a problem. Of course, this is in rands, so you can put the rands if you want. It's not a big deal. And then once we're here, then we know that therefore our equation of the least squares regression line, by the way, B is the gradient, so we start with A. So this is 1730,23 plus 13,96x. Alright, so that is the equation of the least squares regression line. Easy. No business getting this one wrong, okay? So obviously you're getting a mark for each, and that's it. So we've got 1.1.2. So it says predict the sales for a year in which the company spent 28,500, and this one is within the domain because if you look here, these range from 30,000. Sorry, they range from the smallest, which is 21,000. So this is the smallest value. Okay. And then the greatest value of these ones here is this one. Okay. So essentially 28,500 is within that domain. So this is what we call an interpolation. So it is pretty accurate. So we know that, okay, we're looking for something like this. Then we put our X value, which is 28,500. So that will be in rands, okay? So we've got 1730,23 plus 13,96 into 28,500. So here you just need to make sure everything is in order. So I'm getting 3,995.90. 23 cents. Okay, so you can see this is within these values that we've got here as well. All right, Yeah, because again, what was the biggest value on this situation here? The biggest value looked to be this one. Right. And then the smallest value looked to be 311. Okay, so that is the story. Sorry. So that is the story. So guys, you need to really flow here. I know I'm wasting time unnecessarily. So substitution, the answer is what we need. So 1.1.3 says write down the correlation coefficient of the data. So that is R. So we go back, shift, stat, reg, which is regression, and then we press 3. That gives us R. The correlation coefficient here is 0.98. Okay, you get a mark here. So you can see it's very close to 1. So it's a strong correlation, or you can say it's a linear relationship. And then it says describe the association between the amount spent on the advertising in the original newspaper and the sales of this company. We can already see from that correlation coefficient, since it's very close to 1, we simply say this is a strong correlation, or we can say it's a linear. Let's just say it's a strong linear correlation. That's it, because it just said describe, so that's all. You get a mark, and that's it for 1.1. So we get to 1.2. 1.2 says the profit that the small company made over the 9 years is given in the table below. So we're talking about the profit now. It says calculate the mean profit made over the 9 years. Again, this is all calculator work. So for us, if we're looking for the mean, so here we want the univariate data, but now I think I need to do something to my calculator before I run into problems. So here we want the one variable, so it's going to be option 1. And then here we've got 110,750, 107,376, and we've got 152,338, and we've got 244,480. 144,021, 275994, 121,900, and we've got 207,636, then 187,700. So there's 9 data points there. So we are sorted. So here again we go to shift, stat. This time we go to option 4, which is VAR or VAR. Okay, now we want the mean, so that is option 2. And then we get an answer, so that is that X bar. So we know that the mean is going to be in rands 172,466,11, because we are rounding off to 2 decimal places. Alright, so that's easy. So you're getting 2 marks. So that is just calculator work. Now it says write down the standard deviation of the data. So the sun, so this was meant to be here too. So this is 1.2.1. So we've got here 1.2.2. We are to write the standard deviation. So we go back again, shift, stat, var, and then the standard deviation is option 3. So the standard deviation, sometimes you can write it that way. In terms of our x is going to be 56950.09 cents. Okay, so that is our standard deviation. So easy. And then it says determine the number of years in which the company made a profit that was greater than one standard deviation above the mean. Okay, now we want to know what is that. So we've got 1.2.3. so obviously we want to know what is one standard deviation above the mean. So we can say one standard deviation above so one standard deviation above mean is going to be the mean plus that standard deviation. Okay, so the mean we got 172,466,11 plus this one we got 56950.09. So let's see what is that. So we've got 172,466.11 plus 56950.09. So this one is basically 22. Sorry, not 22, but it's 229,416 rands 20 cents. All right, so that is one standard deviation above mean. Therefore, it will take how many years? So let's see what are those values that are above this value here, because we want to see anything that says 110, 107 is less, 152 is less, 244 is correct, it's above 229, so 275 is above 229, and then yeah, that's it. So it's just 2 years, because the rest of those profits are less than that value. So it was just 2 years. Therefore, it was only 2 years. Okay, you can even write just 2 years. So what is important here is knowing exactly what you're looking for in the answer. Okay, sometimes if you just show up with the answer because you are not really forced to do a calculation, but of course you cannot just look here and be sure. So the most important is finding this dude right here. Without this dude, it's almost difficult to figure out what's going on. I don't know why it took so long answering this question of statistics. This is not good. Okay, let's get to question 2, folks. Now here we're going to be dealing with grouped data, right? You always have a question on this. So now it says the ages of people who attended a music concert was summarized in the table below. So we can see from 5 to 15 there were 20, 15 to 25 there were 25, 25 to 35, 60, and so forth. It says now write down the model class of the data. Obviously the model class is the one with the greatest frequency. So the biggest frequency here is 90. So that would be the model class. So this was, adults basically. So 2.1, we will answer it like this. So we know that x is less than or equal to 45, but greater than 35 years. That's it. So you get a mark for that. 2.2 says how many people attended the music concert. All right. Now, that is a situation, I am telling you. Because what should it be? What should it be? It's all of those frequencies, is it not? Yeah. It's all of those frequencies. So let's see. This is going to be 20 plus 25 plus 60 plus 90 plus 55 plus 40 plus 30. So there were 320 people. Okay, so easy again, because all you do, you just, do those cumulative frequencies and you're sorted. That's the easiest. Now it says, on the grid provided in the answer book, draw a cumulative frequency graph or the ogive to represent the date above. And pay attention to how you pronounce this one. It's an ogive. Okay. Not anything else, but ogive. All right, great. Now, we need to do this business here. We know that when we do the cumulative frequency graph, what do? We always take the upper classes of each situation, right? We always take the upper classes. And then we do cumulative frequencies, meaning for the first one, it's obviously going to be 20. For the second one, it's going to be 20 plus 25. You get me? And then we keep going like that. So this is easy. So I do not have that graph. Sorry. So, but let's see if we cannot find it, because sometimes it helps to know how to work on this thing. There it is. So we've got some fancy stuff here that we can use. We can use some stuff rather than to sweat. We just take the things and put them where we want, So nice. So you see, these gadgets, I really did not take them seriously at first, but now I regret not doing it. So this is 2.3, right? Okay, let's first deal with this thing. Okay, so I'm sure you can see here, I don't need more. So this is now, maybe let's just move it a bit further down. Hi. Utheni uyakekela sonhlanyela wena. Hayike. Iyakekela, so this is 2.3. Okay. So what is important here? We can see that, okay, all right, okay. You may want to do something here and perhaps do the cumulative frequency don't here, because it's going to hurt if you don't. Let's just forget it. So we know what to do here, right? So we know that the bottom will have 0, right? Right, because that would be the top of the lower class that starts from 0 and it has no frequency there. So basically at 0 we have 5. So this is going in 5s. So we can simply say, look, they have already chosen the scale for us anyway, so we don't have to worry about other things. So 15 is halfway between these two, right? So this is 10, 12, 14, 16, 18, 20. So these guys are crazy. So they decided it's going to be 15 right in the middle. So maybe let's look. Let's put something colorful. So this is designed to waste your time because they're choosing a scale that is a bit silly. So 15 goes with 20. So again, this is going in 10, 20, 30. Wait, it doesn't. So this is like 1, 2, 3, 4, 5. Yeah, this is 10. Yeah, something did not go well here. This thing was meant to have a line passing through here. It didn't come out all right. Okay, all right. So we've got 15 here in between, and then we're saying this one goes with 20, so this is 10, 20. So this one would be here. Okay, I don't know if you can see, folks, but yeah, that's where this thing is. Yeah, bad. So there it is. And then now the next one. Okay, guys, this thing is I don't know. Let's do it. The next one is going to be 25. Remember, for 25 we're going to add the previous 20. So it's going to be 25 plus 20, which is going to be 45. So 25 is here. So 25 goes with 45. We always add the previous. So we've got 40 over here. Then 45 is in the middle. Yes. Oh, Nkosi yami. Lento izongigulisa le. Okay. Yeah, it's a bit tedious now. Next one. Got 35, so we're going to add 60 to these ones that we've got. So 105. So 35. This thing is just boring, you know. They chose this deliberately because they know you're going to sweat here. 35, we're saying it goes with 105. So this goes here with 1. 105 is right in the middle. Because it's not going to be accurate, guys. The main thing is just to get the thing right. Okay? That's what is important. And then, of course, here at 5, so this is 2, 4, 6, 8, 2, 4, 6, 8, 10, 2, 4, 6. So here, wait, 2, 4, 6. So here, this thing likes to do what it's doing and it's irritating me. So that's where 5 would be, right? The anchor. And then this thing is just irritating me. But, yeah. This is just one of those moments where you just take a bit of your time and don't stress. The next one is 45. 45 is here. So 45 being there goes with, we just add 90 to that, which we have. It goes with 195. So 190 is here. So 195 is here. Yeah, here make sure, guys, you don't mess up. Make sure you don't mess up because you have to use the grid they asked you to use, ne? Otherwise it's easy to do your own thing. Then 55, yeah, this thing is, lighting is boring, man. Then 55, we just add the 55 to this. It takes us to 250. So let's go up to 200. 250 is right on that line. And then 65, yes. $65 goes to, we just add 40 to this thing, then we get 290. So we move up there. 290 is here. Okay, there's 290, and then 75, the last one, final. 75, we just add 30 there. It gives us the 320. The 320, so move down. So this one moves up to 310 and 20 right there. Okay, so there we are. Now we can draw our cumulative frequency graph or the ogive. So all we do is just connect these things. Okay, so that is the stuff that you expected to draw or show, whatever. Maybe we can make these points look outstanding a bit now that we've got some structure. So it's not easy, eh? This one just chose to work on its own. Yes. It didn't do what I wanted it to do. So let's do it again. Okay, so that is the stuff that we were expected to do. I hope it's clear. Yeah, I took a bit of a moment doing it, but in any case, there it is. We've done our ogive, we get our 4 marks. So what is important here? How do you get the 4 marks? Of course, the shape of our ogive is what gives us the marks, right? Right. And then x-axis, of course, those little marks there, you know where we had to do it is where the marks come from. And then also working out these little points. So I'm just going to mark 1 point. So we've got 3 marks, right? And then the anchor, which we needed to find. So I suppose this is where the 4 marks come from. Anyway, that was a bit tedious, but it's part of life, is it not? Now it says use the cumulative frequency graph to determine the median age of the people who attended the music. Now the median is always the half mark. So now we know we've got 320 here as our total. So we just divide that by 2. It gives us 160. So 160. So we're looking at the cumulative frequencies, right? Halfway of 320 is going to be 160, which is here. And then we just draw a line going into our ogive. And then from there, it looks like it's very close to, of course, it's not really coming out properly, but it looks like it would have come down straight like that, just to simplify our lives. So that would be where the median is. So this is 40, 42, 44, 46, 48, 50. Yes, that is age is 42. So to answer 2.4, it is 42 years old, 42 years of age. Yeah, that's it. That's it. So you get your mark there. Easy stuff. So, of course, guys, I've taken forever. This is something you need to answer within 20 minutes. I mean, think about it. I don't know why I took forever, but anyway, don't punish yourself if you take forever. Let's get to analytical geometry. So this one was the easiest. As you can see, you will always get something around the ogive. You get something around, you know, calculating means and stuff. You get bivariate data where you're doing the correlation coefficients. So this is easy to get around, and you know that you go into that exam knowing you're going to pick up marks on statistics. It's never really difficult. It is one of those questions where if they start asking a nice question that is hard, yeah, perhaps a bit of your logic would have to come in. So anyway, let's get to question 3. Now this is the section where easy marks are, but some difficult questions are also there. All right, so we're told here in the diagram the equation of line AF. Where is AF? There is our AF. Okay, the equation of the line AF is minus x minus 11. Okay, so it's already indicated for us, so we don't have to struggle. Now a point on the x-axis, sorry, P is a point on the x-axis. Where is point B? There is point B. Is a point on the x-axis is the midpoint of straight line joining A and C. So meaning B is the midpoint of this line AC. Okay. Okay, all right. And then of course we are told that this is parallel to that, which is very important. Anyway, so we can see that that is what we are told. Maybe let's mark it differently so that we don't miss it. And then what is the next story? A is -1:t, which is fine. And then C, we don't know the coordinates there, so this is just x is to y. Now let's see the angles of inclination of AF and AC are alpha and 63,43 degrees respectively. AF cuts the x-axis at E. Okay, we can see that. D is a point such that DE is parallel to AC. Okay, that's fine. Now we've got everything we need. So what can we do? Well. We've got the gradient of this line. So that means, we've got the angle of inclination. We can actually use that to find the gradient of that line. But we are not at liberty to find the equation yet. But the only way we can find the equation is if we take this point and we substitute there to solve for t. Once we have a point lying on AC, we can use that point together with the gradient, and then that can help us to find. Okay, so that will help us to find the equation of that line. Sorry for just the interruption here. And then AF already have the equation, so we can work out the x-intercept E. Okay, easy, which is simply going to be -11. So we know that at E we are looking at -11. Okay, because if we work out here the x-intercept, it gives us -11. We are sorted. Now that means we can actually find the equation of this line, DE, because parallel lines have equal gradients. We've got a point through which this line passes, and we can essentially find the equation of DE. Great. Now knowing that we can find the coordinates of this point A, and we certainly can determine the equation of that line AC, we can work out the x-intercept. Knowing what the x-intercept would be, we can then work out the coordinates of C. So these are some of the things you do to sort out analytical geometry. Basically, the best thing to do in analytical geometry, just analyze. Okay? Analyze. Okay? Bearing in mind that you're going to need all maths. So for analytical geometry, all maths concepts from algebra to trigonometry to Euclidean geometry, you need those. Okay? So that is the mental preparation for this section essentially. You make sure you maximize on your analysis and you use all mathematical concepts that you have learned. Okay? From algebra to geometry. Okay, let's go on and start answering some questions. Now we're told calculate the value of t. That's easy. The question says calculate, so you're not going to show up with just an answer. All right, again, pay attention to the language of questions. Okay, pay attention to that language, because you answer as you are directed, not otherwise. Okay, so let's go for it. 3.1 has 3.1.1. So we know here that, well, we know that find line AF is such that y equals minus x minus 11. Then through point A, which is minus 1, is to t, it will be such that t is equal to minus into minus 1 minus 11. So that becomes 1 plus 11, which is minus 10. Easy stuff. So, anyway, so that is it, guys. Easy substitution. Answer is how you score the marks. 3.1.2. It says now the size of angle alpha. Now angle alpha, we know that definitely the tangent of alpha is going to be equal to the gradient of AF, isn't it? Yes. So this means that tan alpha is equal to minus 1. Okay? Because the gradient of that line is minus 1. Okay? Here's the stuff. And therefore, we know that our alpha is an obtuse angle. So this is going to be 180 degrees minus the shift tan of minus 1. Or the inverse tan of minus 1. So 180 minus arc tan of minus 1. It gives us, no ways. Suppose it's a win. Okay, if we're going to put a minus inside, it must be a plus here, okay? Or if you put a negative there, you're gonna put a positive inside, okay? Yeah, 180 plus shift tan minus 1. So this is 135 degrees. Easy stuff, not a problem. Again here, you're getting marks and you move on. So let's just keep moving without wasting time. Now the next question says calculate the gradient of AC to the nearest whole number. Okay, so it's easy because we know that the gradient of AC is going to be the tangent of the, what is that angle? 63,43 degrees. So this one is very nice. Therefore, MAC is going to be tan of 63,43. Now, to the nearest is just a 2. Okay? Great. So, again, here you're getting a mark here. Perhaps a mark for that, or a mark for that as well. Anyway, so it says determine the equation of AC in the form. So easy question here, because we've already worked out what T is. It's minus 10. So easy, no problems there. So 3.2, we know that AC is such that y equals mx. Actually, let's not even write mx now. We know the gradient is a 2, so it's 2x plus c. Okay? Then through point A, which we just found out what it is, so it's minus 10 equals to 2 into minus 1 plus c. Therefore, c is going to be equal to, now it's going to be minus 10 plus 2, which is minus 8. Okay? Therefore, y is equal to 2x minus 8. So easy. No problems right there. So pretty simple and straightforward. Material. Ne. Yeah. So here it's working out the C and writing the equation, I suppose. Awu, ndibhala ntoni? Suka nje sekubhaleka into engekho. Hayi. Uthakathi. This is witchcraft, okay? Anyway, so let's get to 3.3. 3.3 says calculate. So again, you can't just show up with an answer. Calculate the coordinates of C. Okay. Now, for us to work out the coordinates of C, we need B first. We need to work out B. Because without B, C becomes a bit of a situation, is it not? Yes. So now let's have a look at so we can say B is such that 0 is equal to 2x minus 8, right? Which implies that x is going to be equal to 4, right? Right. Therefore, B is this point 4 is to 0. Again, why are you saying this thing? It is the x-intercept of AC. You can write that to suggest that that is line AC. Okay? Not a problem. So you needed that because without B, it becomes a situation that no one likes. All right, now that we know what is going on, what do we do then? Then this implies that C is going to be something like x at C plus x at A over 2 is equal to x at B, its midpoint. So the same story says y at C plus y at A over 2 should give us y at B, its midpoint. Easy stuff. This also implies that our C is x at C is basically x at C minus 1 over 2 is equal to 4. Y at C minus 10 divided by 2 is 0. So therefore C is going to be, cross multiply the 2 there, we get 8, we add 1, it's going to be 9. And then you cross multiply that, it's 0, transpose the 10, so it becomes just 10. Okay, so that is the coordinates of C. Easy stuff, ne? Easy stuff. So nothing difficult in here. Alright, so we were getting how many marks there? 3 marks. Of course, the important part is finding the coordinates of B and then those coordinates. The rest is an expected, procedure from you. Again, I did not follow things the right way. I don't like things that are not orderly. Things that are not orderly, they say a lot of bad things about a person. Okay. That is the story that we can tell. Alright, so we've got 3.3.2. We are told to find the size of the angle FED. Now FED, so this is the angle that we're looking for. So we're looking for this angle over there. Alright, okay, alright. So what should be the planning that we need to exercise to sort out this thing? First of all, what I would like to do is to say, look, this line, if we extend it, like that. Remember, this line is parallel to AC, so that gradient is 2. Okay, that is important. It's not a big deal. We can see that. So what is important is that it will tell us that this angle right here, it says this angle right here is the same as that angle. Right, because that is the corresponding angles, because we've got parallel lines. Easy stuff. Maybe let's not shade because the shading is just not helping. So let's just use a color. So it means this portion of the angle is going to be equal to that angle. But now what do we know? We also know that this is vertically opposite this portion right here. So knowing the size of that angle, that it's 63,43, already we have a portion of FED that is already 63,3. So just using those principles. Now all we need to find out is this little portion right here. Now our job is to find this lovely portion. And then that lovely portion will come out when we do what? We use this gradient right here. But we will take that negative angle that we get. We're not going to adjust it. We take it as it is. Or we can use alpha to work out that small angle. And that makes our lives a bit easier. Okay? Makes our lives a bit easier. So let's just go on and start working our things. But now I don't know what we're going to say is this point, because we certainly need some point here. Since we've got A, B, C, D, we can A, B, C, D, E, F. Let's call this point, say, P out of convenience. Let's put that point on the x-axis so that we make our lives a lot easier. So these kinds of questions you don't answer without a bit of a plan, because it kind of causes problems. And then again, this story here, what are we going to say about it? Maybe let's call it Q. Okay, not a problem. So what we're going to say here, we're going to say, first of all, we want to explain our construction. We're going to say, let P be the point on the x-axis as shown. Okay, please, you make sure you indicate on your diagram. You can say also, draw DE produced to Q. This conversation is pretty important because you can't do things and we don't see them and we don't understand what you're doing. We have to follow you, right? Right. Now that we've set up our attack, now we're at liberty to say, well, we know for a fact that, number one, we know for a fact that we can say our first statement, we can say Q E O is equal to 63 degrees. 63,43 degrees, right? Right. The reason is this is corresponding angles. Why? Because we know that AC is parallel to DQ. So, someone knows. We don't have to overly explain at times. We know that this was given a size. We don't need to name it. We just put the value there. Someone will understand why we are doing that. So, you see, with all of the production that we've done and letting a certain thing be whatever, now we are in a good mood to fight our battle. What is the next step? We can say, therefore, what? We know that P, E, D is also 63,43 degrees. What is the story now? These are vertically opposite angles. Okay, as you can see here, they form a crisscross. That line DQ or QD forms a crisscross with the x-axis to form that vertically opposite angle. That's where we wanted to go. Number two, we know for a fact that tan of -1, but maybe let's name an angle first of all. We know that FEP is equal to the tangent of -1, which is the gradient of that line, AF, okay? Which is going to be equal to, now we're just going to take that negative angle here, so we don't need to correct for that situation, because they're going to give us a negative angle. No. Shift 10. What are you doing? What are we doing? So we're going to have shift 10 -1. So it gives us a 45 degrees. So you're not going to write the negative version. You write an absolute value. Sometimes you may even decide that you're going to put these things and say it's going to be the absolute value of shift 10 -1. Maybe it's nice and fancy to be mathematical about your things. Now, what do we know? Now we can say there, then, we know that FED, the Fed, is essentially going to be equal to PED plus, what was that one? It was PED and FEP. Okay, it's obvious. There's no need to be Okay, you can just say C diagram. Now we worked out paired is 63,43 degrees plus now 45 degrees. So we've got 63,45 plus 45. We're getting 108,43 degrees. So this one is 3 marks, but yay! Niyakuxelela is a situation, I am telling you. Is a situation. You can see here we had to do a lot of things. So I don't know, guys, what would be the story here. But one thing for sure, that is an answer. And perhaps we can say this substitution is important. And perhaps this one, because it became a bit of a calculation. I don't know. The 3 marks can be anywhere. So other things are just a means to an end, but they are not really an end in itself. So I don't know. You decide where this thing is. Okay. Now, last question. It says G is a point such that EAGC, okay, in that order is a parallelogram. Okay, so let's see. EA, let's see, they gave us EAGC in that order. So E to A to G. Okay, so basically let's just draw it blue and say this E to A. Now constructions come in, and then we go to C, right? And then, well, it's probably going to do stuff like this. I don't know, so it's something like that. Okay, so we've got an idea. The most important is just to get a clue. It's not a big deal. So we're going to call this one G. Okay, so G is X is to Y. Not a problem. I went bal. Chin. I funu. Okay. Iyalubhala. Yanhlanyela. Batseba itawuwe jwale. Anyway, itawuwe ntsele jwala rena taba le yona. If you can see here, this one actually goes in there like that, is it not? But it doesn't really matter. What do we know? If this is a parallelogram, we know that the diagonals of a parallelogram bisect each other. Right. So this one is going to be equal to that one. And we know for a fact that we are going to use this to find these coordinates right there. Okay? And once we've got those coordinates, what do we need? Okay, let's forget about the other things. Now the question says determine the equation. Again, determine the equation of the circle centered at G. So G is our center and passing through the point B. So B is the point on the circumference. So we already know the coordinates of B. But at no point did we calculate the coordinates of E. So we're going to need the coordinates of E. And we also found the coordinates of C. Could they help us? Could the coordinates of C assist us? Yeah, doch. Anyway, let's not waste time. Let's get to this question quickly. So we've got 3.4. Okay, now we're told here basically we need the center, right? Which means the coordinates of B. So all we can say here is that G or maybe let's start here and say B is the midpoint of EG. What is the reason? We know that diagonals of a palm bisect each other at a point or at the same point, okay? Because we know B is the midpoint of AC. That is already a diagonal. So that means the other diagonal also passes through point B. So what does this imply? It implies that G is going to be the point where, Lord. Okay, let's not rush. Let's just be systematic a little bit. So you say you are not supposed to come out first. The first statement to come out is this one. We know that E is such that 0 is equal to minus x minus 11, right? Right. This is the x-intercept of AF. Okay, so therefore our E, superb. This implies that x is going to be equal to minus 11. Therefore E is the point minus 11 is to 0. So that had to come out. Okay, and then we take our friend right here, say come here. We can say here, but B is the midpoint of EG, and we put that reason that the diagonals of a palm bisect each other. Okay, and then what is the next story? This implies that G is in this manner: x at E plus x at G over 2 is equal to x at B, its midpoint. That same story is going to be y at G. What did I do now? Kalengo E, okay, it's fine. Y at E plus y at G over 2 should be equal to y at B, which also implies that G is going to be x at E, it's minus 11, plus y, superb, plus x at G over 2 is equal to 4. This also says y at E, which is 0, plus y at G over 2 is equal to 0. You see, it becomes an x-intercept indeed. So you see, our drawing is not exactly off, so therefore G is the point. We multiply that by 2, we get 8. 8 plus 11, that is 29, that is 19. 8 plus 11 is 19, so we know that now G is 19, is 2, 0, because 2 times 0 is 0, therefore G is 0 there. Now we got it. Now that we've got the coordinates of G, we've got the coordinates of B. Now we can say this, we can say then the equation of the circle which center G is such that now we've got X. Now we always take the opposite sign. It's going to be minus 19 all squared plus, now y minus 0 is just y squared, okay, is equal to, okay, maybe let's just be systematic. Let's not be silly. Y minus 0 all squared equals, now for that we use the distance formula, but we can already tell that that is a horizontal line. So that's going to be x at G minus x at B. And then we square that thing. Easy stuff. Therefore, that equation is going to be x minus 19 squared plus y squared is equal to perhaps I should not even be wasting time here writing formulae. This is just the same as 19 minus 4. So then 15 squared is 275, or is it 225? Something like that. 225. Okay guys, so these kinds of questions, you can see that they consume a bit of time, because as much as you cruise with as many of the smaller ones, the silly ones, they force you into a bit of a corner. So you've got to do a bit of planning. So as you can see here, since no one ever spoke about the coordinates of E, finding those coordinates of E is a mark, okay? Because they're an important part of what we're doing. But the other 2 marks come from here, finding these coordinates, okay? Those 2 coordinates are important. And then the final answer, however you got to it, as long as you showed how you arrived at it. But that's where those 4 marks come about. And that's it. So we're missing question 4, unfortunately, as well as question 5. So don't kill me. I did not do it on purpose. I only accessed these question papers from Sternmo Physics or SA exam papers. So if there is not a complete paper in any one of them, then I am stuck. Unless if you're watching this video and you wrote this exam and by any chance you have the questions that are missing, please don't shy away from forwarding them to me on my email address, and I will be able to do those questions. But it's nothing really important. Okay, let's not say it's nothing really important, but it's nothing really special. We've done a lot of these questions, so if they're missing, then they're missing. Okay, let's just run and not waste time. Now, question 6 says, in the diagram, the graph of f of x equals 10x minus 45. So if we inspect this one, we will see that there is a minus 45. So what happened? This is a horizontal shift. So this graph has been horizontally translated to the right by 45 degrees. Okay, so that means a standard 10 graph is shifted horizontally to the right by 45 units. So that means whatever was supposed to happen at a particular point will happen 45 degrees later. Okay, we know that 10 of 0 is normally 0, for example. But what happened? It shifted 45 degrees to the right. So now 10 of 45 becomes where it is expected to be. So please, guys, form a habit of, learning these things, because these questions are all about analyzing things. Matric is essentially an integration year for all your school years. So can't arrive at metric, and you are still freezing when it comes to, basic things. Again, we know that the 10 graph has an asymptote at 90 normally. But what happened? That asymptote is shifted 45 degrees to the right. So this makes a lot of sense. Okay? It makes a whole lot of sense. Again, you can even look further and say, there's more you can explore here. You don't limit yourself to one thing. For example, if you look at this line here, so we know that 10 of 45 is 1, isn't it? 10 of 45 is normally 1. But what happened here? This has shifted 45 degrees to the right, because now 10 of 90 becomes 1. So there's a lot of things you guys can look at to try and understand a diagram that you are dealing with. Okay? I was just trying to point out a few things so that you can understand what happened here. Of course, what is the period? The period is usually related to the coefficient of x. So we can see that, well, the period is going to be the standard 180 degrees because there is no multiple before the x. And you can see here, this is a full turn graph. I mean, this is a full turn wave or graph, whatever you want to call it. So if we follow that thing, you can see that this is a full turn wave. But it is between minus 45 and 135. And what is that period right there? So minus 45, we're going to say 135, minus into minus 45 to get that period. It's 1/8. So can you see? So that is essentially how we want things to be. No questions about it. Now let's go on. It says write down the period of f. Easy, we've just worked it out. So you see, interpreting your graph a little bit is exactly what you need, because these questions are straightforward. So we can just say the period is going to be 180 degrees. The question said write down. Don't even demonstrate how you work it out. You walk away with your mark. 6.2 says draw the graph of g of x equals minus the cos of 2x. Okay, for the interval minus 90 is to 180. So they've already given that same domain on the grid given in the answer book. Show all intercepts with the x's as well as the minimum and maximum points of the graph. Of course, when they give you a grid and tell you exactly where to do it, it is pretty safer to do it like that. But I am lazy now, okay? Let me just cut the corners a little bit. But now what do we know? We know that this graph is negative. This means once we multiply the function by -1, we are vertically reflecting. So this is a vertical reflection. This is a vertical reflection of a cosine graph, basically. So that means everything twists around. Or you can say about the x-axis. So we either call it a vertical reflection or a reflection about the x-axis. But at the same time, what do we notice? There's a 2 in front of the x. So what is happening? It means the period is going to be that of the usual 360. Then we divide by the coefficient, which gives us 180 degrees. So that means this graph should complete its full wave at 180 degrees. Okay. But because this is a -1, the amplitude, I'll just say A is 1, because there's no multiples there. So, like I said, please know the critical values for a standard cosine graph. What are they? We know that it is 0, right? Right, it should be 0, it should be 90, it should be 180, and. Okay, those are the critical points that give us an idea. But the problem now is that what was supposed to happen at those critical points, for example, we know that the cosine graph becomes 1. It becomes 1 under normal circumstances. Cos of 0 is 1. Okay, but the problem now is that, first of all, we have a 2 there. Okay, so basically 0 divided by 2 is 0, so nothing changes, so 0 becomes 0. But because now multiplying by negative, it no longer goes into that position. It comes here at -1, because that's where the cosine graph goes. Okay, then we go again for the next one. Usually cos of 90 is 0 itself, right? But now because there's a 2 there, we divide that 90 by 2, it becomes 45. So this cosine graph will be at 0 now at 45 instead of 90 as usual. Then again we go on and say, okay, all right, okay. What happens at 180 degrees, for example? It is usually -1, okay? But now this situation is changing the game a bit. It is suggesting that, look, instead of -1 at 180, now we're going to have to half that, right? Because there's a 2 there. So at 180, it's going to happen now at 90 degrees, right? So that is -1 at 90. But because of the negative, it becomes a +1. So it goes there, all right? So I hope you guys are following, right? If you're not, please watch some of the videos I've shown you already before on these functions. Then the next thing is, we know that cos of 270 becomes 0, right? That's the next point. It's ahead of here, but we know 270 would have been 0. But because now it's going to happen at half of that, so half of 270 is 135. So it becomes right there at 0. Okay, again at 360 it would have been 1, ne? But now because of a negative it becomes -1. But now that will happen at half of that. Half of 360 is 180. So this is 1 right here. Okay, I just wanted to draw it like that. Okay, so that is how the story would go. So it means our cosine graph is going to do stuff like this. Okay. Okay. So that is how our cosine graph is going to go. Maybe I should have chosen another color. All right. That's how a cosine graph would go. And then, of course, you can already tell that because of symmetry, this thing is going to do the same thing here. All right, so these are the points. Now that's how this cosine graph would go. All we have to do is to label it that it is g of x. So somewhere you want to write that that is g. Of course, I just used my diagram there because I want the comparison to be nice. But when they're telling you do it on the grid, let's see what's so special about that grid anyway. Because They didn't give us the damn grid, did they? So they didn't. So you see, I don't know who was compiling this paper. They just killed us. Okay. In any case, I think we did good by not entertaining it. So let's just finish up, guys. We cannot waste time here. We just cannot afford. So we've done the graph, so you can just write here C graph. Okay, not a problem. So we're scoring 3 marks here because I said we must show all the intercepts. So for just mark 1, but there's plenty of them. There's intercept, and then there's a shape. You can see that it's reflected. It's not showing up the way it normally does. So it is a vertical reflection. And the minimum and the maxima. So you can tell that the minimum and maxima at 1 and -1. So you get a mark for those. So that is how you score those 3 marks. Nice and easy. So 6.3. It says write down the range of G. Easy. The range of G is a set of Y values such that Y is less than or equal to 1 but greater than or equal to -1. So it is those maxima and minima. That would be the range. Easy stuff. And then 6.4 says the graph of G is shifted 45 degrees to the left to form the graph of H. Now determine the equation of H in its simplest form. So we know that, well, the graph of H of X is basically the graph of G of X plus 45 degrees. Because a shift to the left, you're adding, okay? So let's go on. So this implies, so this would be equal to, now the graph of, of G, sorry. Okay, is basically minus cos of 2. Now instead of the angle, we're going to put x plus 45. Okay, so this is minus cos of 2x, so you distribute the 2 inside, plus 90 degrees. So that would be the graph of this situation. But remember, once you see a 90 there, you are doing a co-function. So a 90 plus is saying we are dealing with the second quadrant. Okay, so this is minus into. Now remember, 90 plus is the second quadrant, and what is cos in the second quadrant is negative, so it's going to be minus. The co-function of cos is sine, then it's going to be 2x, right? Right, which is just going to be sine 2x. So a little bit of algebra there, or trigonometric techniques is important. Right, so that is cool. Now, you're getting 2 marks there. So obviously, these 2 marks is knowing how to do that. Right? Right. But maybe not there, but here. It's important in the final answer. Okay. Now 6.5 says use the graphs or graph to determine the values. So usually they're not going to tell you how to do this. But already in trigonometry, you want to stick with the graphs more than to do algebraic manipulation, because that can hurt if you're not sure. Anyway, the values of x in the interval minus 92 plus 90, for which f of x is greater than 1. Now f of x is greater than 1, where? Okay, let's have a look. So we see that the graph of f is the 10 graph, is it not? Okay, let's do it. 6.5.1. So the graph of f is the tangent graph. Now when is it greater than 1? We know that this is at 1 at 90 right there. So this is 1 over there. But you can see as it approaches that asymptote, it is more than 1. And then here it is less than 1. As we go on up until we get to that 45. Again, when we get to 90, it is sitting at 1. So in this interval, there's only this portion here where we see that it is greater than 1. So it's as simple as saying x must be less than minus 45 degrees, but greater than minus 90 degrees. Because that graph is clearly positive here. And it's above 1. Okay? So that is where the story is. Otherwise, beyond 90, it would have been minus 1 to that 135, but it's outside the domain that they've given us. So stick with the domain and move on. So that is where the answer is. Okay? Great. So 6.5.2. We are told here 2 cos. Now this one will need a bit of a manipulation. 2 cos 2x minus 1 greater than 0. So we are unable to make a conclusion here. We need to be smart about our things. So basically this looks like the cosine graph that we just drew. So how do we make sure it looks like it? We transpose this guy. So we're going to say minus 1 is greater than minus 2 cos 2x. Okay? And then at this juncture, we can just divide by 2 throughout, so we get minus a half. Now we divided by a positive number, so this sign doesn't change, so it's minus cos 2x. Oh, great. So this therefore says g of x is essentially less than minus a half. So this is the interpretation that you want. Or you can say a half is greater than g of x. I'm sorry, minus a half is greater than g of x. So now that we've put it in a way that makes sense, when is the graph of g less than minus a half? Now remember, cos of 60 is a half, right? Right. But now the angle is doubled, so it's not going to happen at 160. It's going to happen at 120, okay? So, let me think again. The interval that we are given now does not really help us because 60 would have the effect that would happen at 120. So it's not going to work. But what is half of 60 is 30. So that would be 30 because at 30 we would get a half, right? Because 30 by 2 is 60. Cos of 60 is a half. But because of a negative, it becomes minus a half. So we know that, okay, for us to be exactly halfway in our graph, it means we should be at 60 degrees. So it's a bit of an intuitive calculation, you know. So it's going to be 60, right? And then on the other side, because of symmetry, it has to follow the same thing. So again, we look at the fact that this would happen at minus 30. So this one will also be at minus 30 on the other side. I mean at 30 and minus 30. So let's see. To answer this question, we can say, okay, all right, okay. Therefore, our x here should be less than 30 degrees. Because at 30 degrees, this graph is exactly at a minus a half. Then below that, it is at less than minus a half, okay? Same story happens at minus 30 on the other end because of symmetry, but that should be greater because we can see that graph going to the left is climbing, but going to the right, it's going down to the minimum value. So I think this is the story. So what is the story here? Usually this is 2 marks, okay? Great. And then what is the other thing? The other thing that must happen Yeah, I'm not sure what I'm doing now. I'm getting a bit lazy in my mind. My question is, where are these marks coming from? Well. I don't know, man. That is a mark for me. And I don't know, because if you wrote that, this is more or less the same thing here. So I'm trying to see what is the story there. Yeah, Lord. I don't know, man, but these 4 marks look scary. They look scary to me. But either way, if you've got the answer and everything has a logical connection, you should be fine. They will find a way of getting you at the other mark. So always, trigonometric functions are easy. You do not need to be suffering here. So let's do question 7. Question 7 is that important. I mean, these ones, again. So I forgot to tell you the mental preparation for question 6 type of questions. Here, what you need is just like any functions, as you saw on paper 1. Just say, like in any functions. Like in any functions. Here, you pay attention to theory. You pay attention to transformations. I went. You pay attention to the language of questioning. And then all algebra. And then of course some trig, because this is trigonometry. So that is how you essentially, make your brain ready for this, because you will just succeed. It's as easy as that. Okay, not a problem. We are doing great. So let's do question 7. Now question 7 with 3D. Here's the mental preparation for this type of a question. Basically, you just need to know the geometric figures. Okay? 2, you need to know BODMAS. Okay? Both in the true sense, as in arithmetic, and applied in trigonometry. I showed you how to apply that. I'll probably show you again. And then here, calculate all angles. Let's just say calculate all possible angles. Okay, so don't wait. And then the last thing is usually work from the side that is known, okay, or any extra information that is given. So that is the mental prep you would do for this section, because I promise you, you will succeed here. And then of course, you cannot forget trig. I'll just say trigonometry. That means trig ratios, identities, you know them, okay? Area rule, cosine rule, and sine rule. So that is all you need for this type of a question. So it's pretty straightforward, and it's never really that technical. The technicalities is the algebraic manipulations you may have to do. Otherwise, it's usually an easy section. Okay, let's read. Now, in the diagram, A, B, and C are points on the same horizontal plane. And of course, whenever they shade, that almost always suggests the same horizontal plane. D is a point directly above C, okay? So if it is directly above, it already tells you that this is a perpendicular line. Of course, they've drawn it, so if they didn't, you would know it. Okay, that is DC is perpendicular to AC, and DC is perpendicular to BC. Okay, that's fine. it is given that ACB, now where is that? Is this one here. ACB is 100 degrees, okay? And then CAD, okay, coronary artery disease, yani CAD. We're talking about cardiology stuff, is it not? If you eat too much fatty stuff and sugar, you're gonna end up with this one, okay? Careful. Drink alcohol, you're gonna end up with this one. And you don't want that in your 30s when your life is supposed to be, you know, what you wanted it to be. And you're taking treatment because you're careless about how you live your life. But anyway, we don't choose how you should. But just remember, how you chose to live is how you're going to be in the long run. And don't be a sad story, please. Now, AD is 20 units. So there is 20 units there. We can see it. And then BC is 8 units. So there is 8 units. We can see it. And then, of course, it says, calculate the length of AC. Now, if we want AC, we want a triangle that we have a lot of info on. So we've got an angle. We've got the side. And then we want this one. So that is a triangle, a right-angled triangle. So if we focus on this triangle right here, I'm wasting time. If we focus on that triangle, what do we know? We can see it's a right-angled triangle. We want the adjacent side to an angle that we are given. So we simply use trigonometric, what do you call? We just want to use trig ratios. As you can see from our mental preparation there, we're already where we want to be. So we know that, well, always state where you're working. Sorry, in triangle ACD. Okay, don't be haphazard. Don't be careless. You're gonna die. So what do we know? We know that cos of 30 degrees is going to be equal to AC over DA, okay? Which you can just write quickly. You can say, therefore, AC is going to be 20 times cos of 30 degrees. Okay, easy stuff. No need to sweat here. So we've got 20 into cos of 30. So I'm getting here a 10 root 3 units. Here you are not forced to round off, okay? You can leave it like this, or you can take the decimals. It's honestly up to you. So here it's not a matter of just getting the length itself. You can leave it like insert form. There's nothing else that needs to be done there. So substitution answer 7.1.2 says now the length of AB, okay? Now if you're looking at AB, you will see that it's in this triangle right here. But we know that we don't know AB, but we've got that side. We have now calculated that side. We've got an included angle there, which is 100 degrees Celsius. So that means cosine rule. So do you see what I mean? So you're going to say in triangle ABC. What is going on in there? We know that AB squared is equal to BC squared plus CA squared, minus 2BC CA cos of BCA. Okay, so that is the cosine rule. Okay, nothing major. Now let's see, this implies that the BC here we're talking about is going to be equal to the square root of a very long story there. So what is BC? Is 8 squared plus CA, you've got 10 root 3 squared minus 2 into 8 into 10 root 3, right, cos of 100 degrees. Right, so this is easy, just put it in the calculator and you're smart. So we've got 8 squared plus 10 root 3 squared minus 2 into 10 root 3 into 8 okay, into cos, I don't know if this is gonna be right, into cos of 100. Okay, so if it kills me, it kills me. Now this is 20 comma 30 units. Okay, there we go. So these questions were kept simple, eh? They normally give a hard one here sometimes, but yeah, they decided, well, we're not interested in that. Anyway, so you're getting a mark for that. You're getting a mark for the correct substitution. I don't know why they're giving 3 marks, because there's nothing special here. But I guess for identifying the cosine rule, they want to reward you. Okay, let's do the last one. Now, if it is further given that ABD, which is this angle right here. Okay, if it is further given that that angle is 73,4 degrees, calculate the size of ADB. So what we want is this one. Okay, so now we already know that, side 20 opposite that angle that they just gave us, which is ABD. And we also just found out this side, which is AB, which is opposite that side. So here we're going to use sine rule. So 7.2. So I know that fine in triangle, again, state the triangle you're working in, ABD. I know for a fact that I'm looking for the angle, so I'm going to say sine of ADB over the side opposite it is going to be AB, is going to be equal to sine of that angle ABD divide by, divide by the side opposite that, which is AD. Okay, so that is the sine rule. Okay, so this implies that, well, sine of ADB over, now this is going to be ADB is going to be over AB, that we just calculated. It's 20,30. So don't worry about the rounded off. It was already an answer above, so you take it as it is. Then sine ABD, so ABD is 74, sine 74, 73,4 degrees over, now AD, we found out, we were told it's 20. So here you just cross multiply that thing. And you take the sign. So I can just quickly run to the answer now. I can say that ADB is going to be the arc sign of this shenanigan right here. So this is going to be 20 into sine 73.4 degrees over 20. So again, guys, there are some shorthand methods of how to solve issues, but if you're not familiar with them, so don't do it. Go the long route, but the problem with the long route is that you're going to lose time significantly. So sometimes you practice enough to be able to see these things coming, because if you don't, uzovingathi uyatsha mntanam, uzovingathi uyatsha. So asanutsha ke, ndiyanicela. So what I'm getting here is 76.58 degrees. Okay, it's an acute angle, it makes sense. So I'll accept the answer. Alright, so that is the story that we've got, folks. So easy stuff. Again, 3 marks, I suppose. Correct substitution, the answer, and perhaps identifying the rule. They decided to be generous. So this section can be easy, it can be challenging, but the only challenging part here is the algebraic technique, I can assure you. So the challenge here is usually algebra, or should we say application of algebra. Because at times you may be forced to factorize and, you know, do a lot of algebraic manipulations that you don't expect. So if you already are aware in your mind that you can actually be required to use those, or you may actually use those things as a means to an end, you will essentially kill this challenge. Because if the question here is difficult, it's a matter of what techniques you may need to solve a complicated equation. Otherwise, if you follow these things and you keep these little points in your mind when you get through these sections, of course, you cannot do this the first time in your exam, okay? You do this in preparation for your exam. By the time you do the exam, you already are comfortable to some extent with this. And you can use any other survival techniques that are possible. Now let's get to Euclidean geometry. This is the suplexity of paper 2, I believe. Okay? Because this section, if you don't know how to plan, you don't know how to look into the diagram and analyze it properly, of course, within reasonable time, and put the correct attack, it will always take you down. So this one needs you to be logical. It needs you to remember a lot of theorems. It needs you to know the entire maths, essentially. So Euclidean geometry is the whole mathematics as well. It's just like analytical geometry, but perhaps on a more conversation type of a situation, because here you are conversing more than you are doing calculations per se. All right, easy stuff. So let's just run through this quickly and see what we can do. Question 8. Quickly, it says now in the diagram, O is the center of the circle. K, T, L are points on the circle. So once you hear that word, points on the circle, what is the mathematical term for that? We call them concyclic. Okay? Meaning if you join any 4 of them, if there are 4, but there are only 3, but they're concyclic, so they're forming a triangle. That triangle is a cyclic triangle, which comes into effect when you talk about a 10 chord theorem, is it not? Yeah. Yes. But if it was a quadrilateral, we'll talk of a cyclic quad. Anyway, KT, TL, KL, OK, and OT are drawn. We can see that OT intersects KL at M. Okay, we always want to be aware of a point of intersection. And then we're told ST is a tangent. Now we need to know that this is a tangent. Okay, of course, you may mark it, you may not, it's up to you. And okay, at T so the point of tangents is point T, and then STK is 36 degrees, so it's already indicated, but we may just want to accentuate that business. So that is 36 degrees, and OKL is 18 degrees. We also may want to accentuate that so that we can see it nicely. Now let's think. What can we do here? Just forget about questions for a while. Just take some 2 minutes to just look into this quickly. Now, if this is a tangent, we know that the angle between the tangent and a chord KT will be equal to the angle subtended by that tangent, by that chord at circumference. That is the 10 chord theorem. Number 1. Number 2, if this is the center and that is the point at circumference, we always know that the angle subtended by, not subtended, but the angle between the tangent and the radius is always 90 degrees. This already tells you and I that this angle right here is going to be 90 minus 36. Okay, easy stuff. Now, what else can we do? 10 what is needs into slab. Okay, knowing that this angle is 36, we know that the angle at center is twice the angle at circumference for the same chord or arc KT. Yeah, there's more, but this usually is enough. But make sure you understand. We can highlight that OT should be equal to OK. If that is the case, we already know that this angle right here should be equal to that angle right there, because those are the base angles of an isosceles triangle, or angles opposite equal sides in triangle KOT. Now, once you've done that, you stop, okay? Don't overly do it because it can hurt. Now, let's look at the questions. Determine, giving reasons, the size of course, determination can be by just inspection, can be by some calculation, whatsoever. But here you are supposed to provide a reason for your stories. Now, T2. Now, we can see how T2 comes about. So, we've already done half of the work. All we do is just transcribe our business. So, we've got here 8.1. 8.1.1. So, we know that, well, angle T2 plus angle T1. You start by there, so that whole angle there, or you can say OTS if you like, is equal to 90 degrees. Oops, what is that? We know that the radius is always perpendicular to the tangent. So that is it. So this implies that T2 plus, now T1, we know it's 36 degrees, is 90 degrees, therefore T2. So we're just trying to be a bit complete here. Don't want to be weak, people. You know, sometimes you gotta love what you do, man. You gotta love what you do. Don't hate it so much that you always want shortcuts. They will kill you, those things. Okay, easy. So usually that statement and the reason is important. Here you're getting the last mark. If I was the one deciding, I would say for substitution again. So this would be 3 marks because it's not as simple as they make it look. Anyway, so that was A again. Oops. Oh my Lord, tired of this thing. Ke kgathetse ke ntwe ena wa tseba ya ntena jwale ha etsa so. Wa bona ha etsa so ha ke raten asintwane ba ang rata ke etsa so. Yes, so I get so one rata ke etsa so. Ha ke etsa jwang hantle. Hobane o sa hlalose mon ha re bone ntho o buang ka yona. Go betere o thole fela ska bua ha iba ha re bontshe ntwe. Anyway, L, let's look at L. L is easy, so we know that, well, angle L is going to be angle T1. Okay, what is the story? This is the 10 chord theorem. Therefore, angle L is going to be 36 degrees. Nice and easy. Now let's look at KOT. Now, what is the story about KOT? Yes, angle KOT is going to be equal to 2 times the angle L. We know that is the angle at center is equal to 2 times angle at circumference. This is 2 into 36 degrees, which is going to be 72, right? 36 by 2, yeah, is 72 degrees. Nice and easy. So again, statement and answer there. Easy. So usually this part of Euclidean geometry is a warm-up, okay? It never is that difficult, so you just take all the marks for this part. Now it says prove giving reasons that Km is equal to ML. Okay, so if we're saying we want this situation, or that shenanigan that, so we want this shenanigan here, so to be equal to this shenanigan on the other side. Now, how can that stuff be possible? I call water resistant kabase yaphanya zangokhina bafundi davuzisa ngokosana. We want to prove that those two are equal, but remember this OT is a line from center. This KL is a chord. So how can we bisect a line, a chord into 2 with a line from the center? We know that it is only when, it's not a must, but this condition is that only when, this is proven to be 90 degrees, right? How do we prove that? We prove it like this. If you look at this triangle right here, look at that triangle. What do you see? We were given that opposite angle. The 2 opposite angles we essentially know. We just found out KOT, we just found out. So this is an exterior angle. If we prove that exterior angle is 90 degrees, then we know that when a line drawn from center and it is perpendicular to the chord, it essentially bisects the chord. So that is theorem 1's converse or whatever. Now we're going to say, look, in triangle KOM, Come is so man. Hey, I will donor this thing. What do we know about Fuato? We know that OML is equal to KOM KOT plus K2. Alright, this is an exterior angle of a triangle. We've already stated which triangle we're talking about. Now let's see, KOT, we found out it's 72 degrees plus they're telling us that that is 18 degrees and this is definitely 90 degrees. Ho, 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 ho. Holy cross. So we can say therefore, KM must 2 can be equal to ML. Why? Because line, I don't remember what theorem 1 says. I would have said converse of theorem 1, but now I'm not happy. We can just say line from center perpendicular to chord. Easy. So a line from the center of a circle perpendicular to chord will bisect the chord. Nice and easy. Okay, that sounds correct. I mean, they made this question so easy. Why? Are you guys tired of asking questions? You've been silly all along. So that is the story, and then that is the story. Easy warm-up. So let's get to 8.2. Now 8.2, I must bala up. So 8.2 says in the diagram, triangle RDS, okay, is drawn. Okay, ABC are points on RD, RS and DS respectively, such that, okay, everything they're saying is drawn. Okay, and then we're told RB divide by BS. What a choice of word. Some BS right there. Now they're saying it's 5 over 3, so we're just going to choose a multiple. They say 5a, 3a, because this is a ratio, so that 5 is not units, okay? So always choose some variable to go along with those values to keep them in proportion. And then DC is 20 units, so we can see you, sir. And CS is 12 units, so they love Caesarean sections, yeah, when. Anyway, let's have a look here. So we can tell you're dealing with the proportionality theorem, right? Right. So there's nothing to really worry about. Of course, for Euclidean geometry, so all the theorems from grade 11, in fact, from grade 4, if there is a theorem there. Let's go. So now it says, prove giving reasons that BC is parallel to AD. Okay, BC must be parallel to AD. So the way we want to look at it is to look at this triangle in this manner. We want to look at that triangle in that manner. All right, okay, all right. Bantram, man. So I want to look at it like so. So look at that. We want this side 2 over that side, is it not? Yeah, that is the best way we can try to do this thing. Otherwise it becomes a bit silly. So let's just say SC over CD is going to be 12 over 20. Now we know that 2 goes to 12. Now let's not choose 2 but 4. The highest common factor between these two is 4. So 4 goes 3 times to 12, goes 5 times to 20. That is how we can simplify this one. And then we can say also what? We know that SB over BR is going to be 3A over 5A. This is the same as 3 over 5, as the A's will cancel. Great, but now what do we see? We can say therefore CD over SC, man. Superb. SC over CD is equal to SB over what is this? BR. In fact, we should have stated that in triangle RSD. That's what we're talking about, okay? Now, if that is the stories, and because they are of the same ratio, right? Because they are each equal to this 3 over 5. You get me? You get me? You get me? We can say if then this line CB divides these two opposite sides of that triangle in the same proportion, it already tells us that CB, or is it BC? What did they say? Yeah, BC. Let's write it the way they want. BC is definitely parallel to AD. Now, what is the reason there? Remember, we say if one line is drawn parallel to the third side of a triangle, it cuts the other two sides in the same proportion. But now we started discovering the proportions. Then we're doing the converse. So we can just write here converse of prop theorem, because we proved what comes after something has been declared parallel. Now the opposite is true, is it not? Yes. Yes. So where are the marks here? Of course, that one was great. This one is, man, come on, but this one is easy, ne? But yeah, doch. Easy, 3 marks. Let's just move. Now it is further given that RD, so this dude is 48 units. Okay? Calculate, giving reasons, the value of AD over AB. But we just found out that this line is parallel to this one. So do you see we have a parallelogram here? We've got ourselves a parallelogram. Yo. This one is a palm. It's because there are no more questions to chase, man, after this one. So do you see that's a parallelogram? And if it is a parallelogram, what are the properties? It is that these opposite sides are equal. So if this is 20, therefore AB is 20 units because of a parallelogram. So we already know what AB is. So our challenge is finding AD. What is AD? But we're going to use proportionality theorem to find AD. From this triangle, again, we come back and say, we can say, this is 8.2.2. Where can we start? We can start by saying AB is equal to, let's just say, is equal to DC. What is that? These are the opposite sides of a parallelogram. That's what we know. Maybe let's state which one, because they will probably be interested. It's AB, CD. Now they will start to see it, won't they? Which is 20 units. Okay, that is the first argument. We can say then in triangle RDS, what can we say there? We know that, look, AD, because that's what we're interested in, over the whole side of RD in that triangle. Because we're told AB is parallel to DS, so we can just use that proportion. It's going to be the same as BS, what a choice there, over RS, okay? Again, this is now prop theorem. Always state the set of parallel lines AB is parallel to DS. Okay, that was given information. So this implies that AD over RD is 48. Just a moment. So over 48 equals that BS is basically 3A over RS is going to be 8A. Okay, you add up those things. And then, of course, because these are ratios, the A's will do the thing. We cross multiply the 48 quickly. Therefore, we know that AD is going to be 3 over 8 into 48. What is that? So that is 6, is it not? Is it 6 or is it 5? 8 by 6 is 48. I know it. Yeah. So 6 by 3 is 18 basically. So that is going to be 18 units. Sonhlanyela. Hey when. Obatla honketsang jwale. Yeah man. 18 units. Therefore, AD over AB is going to be 18 over 20. Okay, which is, now 18 and 20, there's only 2 that goes in there. So 2 goes 9 times, to 20 it goes 10 times. That's it, guys. Okay, maybe you can write it the way they want it. Okay. Always try to maintain the question. Do your own thing on the side and then sort it out eventually. So this one was not quite simple. I don't know why they're just giving it 3 marks. It's a bit of a gymnastic, don't you think? Of course, that statement will always be priority. And essentially getting the 18 because we did not know it, and eventually for the answer. Okay, so let's get to question 9. Some more Euclidean geometry. Okay, so now the story here is that in the diagram O is the center of the circle, and then ABCD is a cyclic quadrilateral. Okay, that is, we can see that these little friends of ours are at circumference of that circle. So those are concyclic points. Nice. Now it says use the diagram to prove the theorem which states that the opposite angles of a cyclic quadrilateral are supplementary, meaning they add up to 180. So they are choosing B and D. So if we want to add B to D, well, I have a special gymnastic that I would love to show you, friends. But I know you probably know the easier one, but I will give you the hard one. Ne? Yeah. You know your common one. Okay, let's start with the special one. Because I'm adding B and D, what I'm going to do, I will just say, look, let's just try and extend AD to say this is ABCD, and then say we are extending it to E. So my construction is to do that. But now what do I know? I know that this becomes the exterior angle of a cyclic quad. Right. So now these are angles on a straight line, because what I want is to know that. Right. But I don't really even need to know it. I don't. But if I can move angle B to here, already this angle D plus this B, which is the same as that, is already telling you and I that these are supplementary angles, and that is proven. Very interesting stuff. And then of course, you know the standard way you're going to go about this. You join AO and OC. Okay, but to show that these are constructions, they must be like this, because they were not there. Okay, so you can either do this, of course, I'm just showing you another fancy way of doing things so that you don't get stuck to just one method. Everything works out perfectly. Okay, let's start. So we're going to say 9.1 starts something like this. We will just say given. What are we given? Is A, B, C, D. Cyclic quad A, B, C, D. So we know that this is a cyclic quad. Okay, now what is the story here? We are required to prove that B plus D is equal to 180. And then what is the construction that we must perform? So here, like I said, you've got two options now. We can just say draw OA and OC, or can say radii OA and OC. Easy stuff, ne? That's all the construction you need. Now, such that at center there is O1 and O2. So you can say this is probably O1, and then the other one is 2 on the other hand. Okay, easy stuff. So you just show what you're showing, and then you can say proof. So what do we know? We know that angle O1 is going to be twice angle B. This is angle at center equal to 2 times angle at circumference. All right, so that is it. You can say also O2 is equal to 2 times angle D. Same reason, angle at center equal to 2 times angle at circumference. So we can say but O1 plus O2 is equal to 360 degrees. This is the revolution. Okay, we can say angles at a point. Okay, so this implies what is O1 is twice angle B plus O2 is twice angle D equals 10 go. Now you factor out the 2. Okay, then when you divide by 2 throughout, we will get that angle B plus D is equal to 180 degrees. Sorted. Okay, so you can go about it the standard textbook way, or the special technique where you can just say angle CDE is equal to angle B. What would be the reason? This is the exterior angle of cyclic quad, because we were told that is a cyclic quad. Then we have a but angle, say for example ADC plus angle CDE equal to 180. What is this? Angles on a straight line. Therefore, we know that this angle was D. Okay, maybe let's start with the other one. Therefore, we know, since we said angle B is equal to CDE, okay, so we can say therefore angle B plus, it was essentially written as D, are equal to 180 degrees. So do you see? Either way, whatever you do, you can see that one is even shorter than the other one, but it doesn't matter. Of course, if you were to use this technique, you would use the construction that we'll just say here, draw AD produced to E. When you say a line is produced, it means it's the same straight line. So that would be your construction. So please play around certain things to display your charisma. You get your 5 marks. I won't even show you where those marks are because it's nothing special. Something you should already know. Now in the diagram, DEFG is a cyclic quad. Okay, so that is the cyclic quad. It looks like I'm gonna chow all the time I thought I was gonna use for the other analytical geometry question and the trick, but it doesn't matter anyway. I don't have those questions, so I don't have to hurry. Now we have been told that this angle here, D1, is X. Okay, well, we can see that. And then there's this set of parallel lines right here. Okay, not a problem. And then what are we told again? H is another point on the circle such that, okay, we've covered those. Yeah, that is the story. Okay, now it says prove giving reasons that D1 is equal to D2. Okay, so what do we do here? First of all, if we're looking at this situation right here, we can see that this angle is alternating with this angle, right? Right, because they form the letter Z. Considering this line is also doing the things. So we've got alternate angles there. Fine. What do we know about these alternate angles? We also know that that dude plus that dude, they add up to 180. Those are supplementary angles, or should we say opposite angles of a cyclic quad. But this dude right there and that dude, they also add up to 180 degrees. These are the core interior angles because of those parallel lines. So we can use that to our effect and see how it helps us. So let's start. We're going to say, fine, we know for a fact that angle G is equal to angle D2. These are alternate angles with DH parallel to FG. So that is what was given. So we are fine. We leave it at that. We will say also, but Okay, maybe let's not say that. Let's just say however. Let's just use some English here. However. We know that angle D1 plus angle F equals 180 degrees. These are opposite angles of a cyclic quad. There's only one quad that we're given there. It's that quadrilateral. Okay, you can even name it if you want. Now, that is fine. But all we want is to express F in terms of that other one. Therefore, we know that angle F is going to be equal to 180 degrees minus angle D1. Okay, just leave it at that. So that is fine. We wanted to isolate this. Now we have a situation that, but, what is the story now, mister? We know that, look, man, angle F plus angle G is also equal to 180 degrees. These are the core interior angles. Again, state the set of parallel lines. We know that EF is parallel to DG. Then now what we're going to do, we're going to substitute F with that which we found. This implies that 180 degrees minus angle D1 plus, what is angle G? Angle G, we know that it is essentially angle D2. So this is angle D2 from what we saw above, equals 180 degrees. And we can see that these two dudes will do the number to each other. And as we transpose the other one to that side, it will be D1 is equal to D2. That is by elimination technique, essentially. So that is the story, because if minus D1 plus D2 gives us 0, it means those two are equal. A very nice question, essentially. So that is important. This is important. That is important in the final answer. Okay, great. Now let's get to the last question and dance. Usually, most of the suplexity happens in question. The last one is always the painful one, because they don't want you to smile all the way, okay? The intention is to quit smiling. Just be, neutral. All right, let's quickly get to this one. Now in the diagram, TR is a diameter of the circle. So where's TR? Come here, TR. Okay. So there was the center right here, supposedly, but they didn't tell us, but we are imagining it to be there. So TR is the diameter. So if TR is a diameter, what do we know? The diameter always subtends a right angle at circumference. Angle at semicircle. Always, always, always put things into perspective. Now PRKT is a cyclic quad. Okay. Where are you? PKT don. This is the dude we're talking about. Okay, all right. This is the dude. Okay. That is the dude. Superb. Okay. Now, what do we see about this little friend of ours? We can see that, oh Lord, have mercy on this man. The man says, whatever. Do you see this one? is equal to that one. If that is the case, it means this angle is equal to that angle. Okay? Because those are base angles of an isosceles triangle, because that becomes an isosceles triangle. Okay. Alright, okay. But we also know that this angle is in the same segment as this one, I win. So those are the angles in the same segment subtended by chord TR or arc TR. But we also know that this angle here, T1 plus T2, is also equal to angle R1. That's an exterior angle of a cyclic quad. Ne? Yeah. And also, if this is 90 degrees over there, it also tells us that we also have 90 degrees here. Again, an exterior angle of a cyclic quad. But at times you don't want to overly do things, eh? It hurts by words. Be careful. Don't be too overly interpretative, but yeah, you try your best, because it will make you not like yourself at times when you don't do things properly. The last one that maybe we want to highlight is the fact that there's a lot of equalities, man. Yes, look at that. That is equal to that. Angles in the same segment subtended by wara. There's more than you can choose here. So sometimes when the diagram gets messed up, you stop, because you don't want it to be dirty. You want to keep it clean. Now let's finish up. It says now, prove giving reasons that SR is a diameter of a circle passing is a diameter of a circle passing through S, okay, P, and R. So basically it says we want to prove that this friend is a diameter. And indeed, because this is 90 degrees from an exterior angle of a cyclic quad. So if that SR subtends a 90 degrees at circumference, seeing that those points at circumference. So it's very simple. So this is an easy 4 marks. Do you see, when you do a bit of justice to yourself by working on the diagram, you become good. So all we can say here is that, number 1, we need to prove that K1 plus 2 is 90 degrees. So what we're going to say here is that K, 10.1. So we've got 10.1.1. We know that, well, angle K1 plus angle K2, they are equal to angle P3. No. First, let's say this is equal to 90 degrees. This is now angle subtended by diameter TR. Okay? Because the angle at semicircle is 90 degrees. We can say, but this P3 is equal to angle K1 plus angle K2, okay? Which is what? An exterior angle of a cyclic quad. Therefore, we know that P3 is 90 degrees as a result. And if P3 is 90 degrees, it already says, therefore, SR is the diameter of circle passing through S, P, and R. What is the reason? It is the converse of what? Angle in the semicircle. Okay, because we found out the angle in the semicircle is 90 degrees. So we've started by finding the angle, then in reverse we proved that that should be the diameter. Nice and easy. So yeah, maniac, that one is important, that one is important, and here I would say 2 marks. I don't know why they're giving 4 marks. Maybe 3 marks would have been better. But perhaps to prove that this P3 is 90 degrees. But I mean, come on. If you're saying that is that, so would you? Okay, maybe let's say the mark is here, and then we give 1 mark here. Yeah, whatever. Whatever. 4 marks in the bag. No questions about it. 10.1.2 says we need to prove that S is equal to P2. So how do we prove that S is equal to P2? It already says prove that this is a tangent. Indirectly it says find that PK is a tangent to this particular smaller circle that we spoke about. But yeah, to prove that is a bit of a situation, is it not? Now we need to be very, very, very crafty indeed. We need to be very crafty. Yeah, you can see the 5 marks. We need to make a lot of connections. But what do we know? We know without a shadow of a doubt that this angle R1 is equal to angle P2. I mean T1 plus 2. Okay? Yeah. Which is itself equal to angle P1. Ne? Yeah. Now that is the story. That is the story. Yo, imag. Imagancini. Khona into engafuna ukwenzeka la. Khona into engafuna ukwenzeka la. Chabana way. But let's look at this triangle here. Let's just be smart. Let's look at this triangle here. So if we look at that triangle, what do you see? We see that angle S plus angle R1 is equal to angle P1 plus P2. That's an exterior angle of that triangle. Ne? Yeah. Yeah. So life is gonna be easier that way. Let's just plan it that way. We'll start by saying, well, first we need to make the connections, right? Let's start making the connections. We know that angle R1 is equal to angle T1 plus T2. What is the story there? This is an exterior angle of a cyclic quad. We can name it. It was PRKT. Okay? Not a problem. That we know. But what do we know? We know that angle T1 plus angle T2 is equal to, angle P1. Ne? What is that? These are angles opposite equal sides in triangle PKT. Right, because we were given, maybe let's state why it is so. We were given that PK is equal to TK. That's what we were given. So we're making the connection. So what are we trying to say? We are trying to say therefore angle R1 is equal to angle P1. I can't conclude like that. Superb. Therefore angle R1 is equal to angle P1. So that is very important. It's a very strong statement to attempt to make, because if you don't make that statement, it will start stating things about you. Now we have a situation that says, however, the English man, however, in triangle SRP, me, I don't really care about how you name a triangle. However, in that triangle, what do we know? We know that angle P1 plus angle P2 is equal to the sum of angle S plus, maybe let's start it the other way around, so that S is a leader. So we know that angle S plus angle R1 must be equal to angle P1 plus angle P2. This is an exterior angle of a triangle. We've already stated which triangle is that. Okay? The triangle is SRP or RSP or PRS, whatever. PSR. You're not allowed. Now, what do we know? We know that R1 is essentially angle P1. Instead of R1, we're going to put P1 is equal to P1 plus P2. Now these two will do the number to each other. Therefore, we know that angle S is going to be angle P2. Nice and easy. No questions about it. Okay, so a bit of planning. We need to work it out. Maybe we cannot say however. Let's just say then. Yeah. Sometimes choose the appropriate leading terms. You see? So guys, we've killed it. Nice and easy. So let's do 10.1.3. Now 10.1.3 says ASPK, triangle ASPK. I never really pay attention though to the actual naming. I only pay attention to the triangles I'm supposed to be looking at. But you guys, you know, some of the shorthand techniques you may need. So SPK. So that triangle together with triangle PKR or PRK, PRK. Wow. Okay, so it looks like we're working with this triangle here. What color can we put in there? This triangle right here. So we're looking at that triangle right there. And on the big one. Then the big one, let's make it this color that we are talking about. So we're looking at that little green triangle. And this one. Great. So that's what we are comparing, right? So let's start. In triangle SPK and triangle PRK. So we know that we can prove equiangular, but we can see that angle S, no, we can see that, okay, maybe let's cut this one here so that we can see. So we can see that K2 is common to both triangles. So we can say angle K2 is common. Okay, it's obvious. There's no question about it. But we just proved above that angle P2 is equal to angle S. Ne? Yeah. Maybe let me switch the order of these things, man, because I didn't work the way I'm supposed to. I started with PRK. And then here I put SPK. It doesn't really matter which one you start with, but I'm just trying to follow the equalities here. Okay, so this one is proved above. Okay, once you prove two sets, the remainder will always be the same. So we can say therefore R2 plus R3 is going to be equal to, in that other one is going to be P2 plus P3. These are the remaining angles. Okay, or you can say 3 angles of a triangle, whatever. Therefore, triangle SPK is similar to triangle PRK. The reason is they are equiangular. You can write angle, 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 or you can just simply write equiangular. Great stuff. So that was an easy 3 marks, you know, because essentially what matters is this guy and that guy. That one was already proved above, so you're not getting rewarded for this one. You already got a mark above for it, and then you're getting a mark for the conclusion. Okay, so far no suplex whatsoever, but this was a mini suplex, ne? Maybe this was a power slam nyan, yabo. A power slam nyan happened here. Yeah, but it's a slam nyan, it's not a big one. And we didn't get a suplex, eh? Yeah, I thought we were gonna be suplexed and all. So 10.2. We're told it is further given that SR is equal to KR. Okay, so SR is equal to KR. Okay. Whew. All right. okay, all right. Now prove that ST is equal to the square root of 6RK. Yar. Yabona nansi lento bendiyithetha. Suplexity, boys. Suplexity. So we're trying to prove that that thing is the square root of 6 RK. Yeah. Now we need to think about what must we do, because we've got skills, man. We've got skills here that we can use to our advantage. You get me? We've got skills. Now, let's see. We've got a right angled triangle STK. we can actually use Pythagoras here to work some things out, right? Because st squared should essentially be tk squared plus sk squared. Let's start there. Say in triangle STK, what do we know? We know that st squared is going to be tk squared plus sk squared. This is now Pythagoras. Okay, easy stuff. But we can see there that we've got rk. So we're going to say this is tk squared plus, instead of sk, because we know that sk essentially is divided into two equal halves that have rk. So if sr is equal to rk, we know that technically sk is going to be essentially 2. So this is going to be now 2 kr, or the root rk squared, which is going to be tk squared plus, when we square that, it becomes 4rk squared. Nice. So now that we've done this, and we can see here we only have rk here. So always inspect what you've got, guys, because that way you will succeed. So you can already tell that the key now is to attempt to showcase this dude in terms of rk. Okay, that is the key now. We need to get tk to have rk as its definition. So the key is that we need use to look like this dude, because if we can, then we know that we already have 4. So this means it has to be 2rk, rk squared, of course. If we can get this guy to be 2rk squared, then that means we're going to have 2 plus 4, 6. Then we take the square root, it's going to be square root of 6 over that. So we already have a clue that we've done half of the job actually. So the suplex was maybe a choke slam. It was a bit of a choke slam. It was not a suplex. It's not a one. It's not the one. It's not the one. So be strategic and be vigilant. These things are not so bad, but sometimes, yeah. But now, how do we deal with this matter so that we succeed? We can say, fine, let's look at this business here, because if they ask us to prove something above, we are almost always going to need it. Can we use those triangles to derive something about tk? The answer is yes, because if you look at, for example, pk is equal to tk, is it not? Because it was given. So we can use pk to substitute for tk. Nice and easy. That's what we can do. But now, if you look at pk is the common side to this triangle, the green one, and the purpley outlined triangle, the one that we outlined purple. So if we have a common side, then we can use our ratios of similar triangles. So we know that, but in triangles, what is this? SPK and PRK. What did we find? We know for a fact that if we use PK, we'll just say PK over. We want to use that. We will just say PK over. Now look at PK. In this smaller triangle, which is PRK, PK is opposite that R2, R3. But that R2, R3 should be equal to P2, P3. and the side opposite it in the bigger one is SK. So that is SK, which is equal to, now we want something that is going to force us to use this side on that triangle. So what will force us? We know that it's going to be P2, right? So this one we're going to say KR or RK. Okay, RK in the green triangle is opposite P2. P2 is equal to S in the bigger one. The side opposite S is PK. So now what do we say? We can just say these are the proportional sides in similar triangles. We know that those triangles are similar, was it not? So we do the gymnastics there. This implies that PK squared is going to be equal to SK times RK. Ne? Yeah. But we have a story again. We have a but. But. No. We can't have a but. Let's just leave it at that. Now, what do we know about SK? SK is twice RK. Right? This is 2RK times RK. Oh, this is going to be 2RK squared. Yawena. Maybe let's do it like that so that it's nice and easy. Of course, you may be asked at this point, what is the story there? You can mention what was further given. Maybe at this point, it would be prudent to state that SR is equal to RK. You know? Because sometimes you cannot say too much. So other things you just add as reasons. Okay, now that is PK squared. Okay. So maybe let's not use a but here. Maybe let's use our fancy word. However, because we want to get to something, we know for a definite fact that but what? We know that PK is equal to TK. Ah, that was given. That was given. Yay! 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 What is the story? This therefore concludes that TK squared is going to be equal to 2RK squared, is it not? Because if this dude is equal to that dude, ne? Yeah. If those dudes are equal, then that means we can express them. Maybe let's try to be a bit systematic before we just jump to conclusions. This implies that now PK squared is equal to TK squared. Right. Therefore, we can say TK squared is equal to, what is PK squared? Is 2RK squared. Now, this implies that now ST squared is going to be, instead of TK squared, we're going to put 2RK squared plus 4RK squared, which is 6RK squared. Therefore, ST is going to be the square root of 6RK squared, which is going to be the square root of 6RK, which is exactly what we needed. Nice and easy. Okay, perhaps that was a choke slam, maybe, because you needed to plan a little bit. But remember, Maths needs you to be logical. Maths needs you to be vigilant. And essentially, you need to be strong, okay? The only way you can get your strength in maths is when you practice, okay? I have given a lot of videos, guys, where I show you exactly the method of nailing any question in maths. So you cannot say to me, you choke to a point of no return when you get to these kinds of questions, because obviously this is a high order question, but perhaps not really a suplex, but maybe a zamokuhlemakhamba. Yeah, but don't choke to death, please. Now, where are the marks? Words. Technically, ndiyayiqonda le nto banyanzelekile ivelile, right? Yeah, imark ikhona phaya. Enye imark ndiyayiqonda futhi ngokuqinisekileyo into yokokubana it is important to prove that TK is this dude. Ne? Definitely. That is important. And of course, that is also important. 3 marks. And then, this gymnastic right here is key. 1, 2. Yeah, but I think it's straightforward, man. I think it's straightforward. So sometimes the marks are scattered, so I don't know where they are, but they will tell you. But at the end of the day, we got them all. Alright guys, I hope you enjoyed the video. And please, if you really want more of these kinds of questions and how to solve them, just subscribe to the channel. And you will have full access to all of them, because I know if you're not subscribed, you may not see all the videos. But if you're subscribed, you'll be able to access all the videos. All right. And that way you can get to experience, you know, something really wonderful that will boost your confidence and essentially give you the best mark at the end of the year. Otherwise, whatever you choose, make sure you make the right choice. Bye-bye.